So these are some worked out problems. So let's start with carboxylic acids. Give the IUPAC name. So we know that we are naming carboxylic acids. If we did not know what this molecule was, we would be looking at this functional group, C double bond O, OH, and then say, okay, I'm looking at a carboxylic functional group. So this is a carboxylic acid. 1, 2, 3, 4. 4 carbons. 4 is bute. Carbon 1, carbon 2 has a methyl substitution. So with all that in mind, analyze butane, butanoic acid. Okay. Identify the longest chain, replace the E with oic acid. So we have butanoic acid. Start numbering the carbons, starting with the carboxylic carbon, 1, 2, 2 methyl butanoic acid. 2, 4 dichloropentanoic acid. So again, I'm going to set up penta, 5 carbons in a row. Carbon 1 has the carboxylic group. Starting number 1 carbon, the carbon with the carboxylic group 1, carbon 2 has a chloro, 3, 4 has a chloro. 2, 4 dichloropentanoic acid. Okay. Carboxylic acids, ionization of propanoic acid. So propanoic acid, acids in water liberate hydronium ion. That is what they do. Every acid is a molecule that can liberate hydronium ion in solution, aqueous solution. So if we are looking at propanoic acid, it's going to form ions. So we say ionization. It's only ionization through ionization or formation of ions do acids liberate hydronium ion in solution. So you can see that propanoic acid, 1, 2, 3, in water liberates hydronium ion, and this is the ion for acids. So propanoate ion and hydronium ion. So this is ionization. Acids ionize in water, aqueous solution or water. So this is the presence of water. Aqueous solution means solution in water. So liberation of hydronium ion and formation of the propanoate ion. Methanoic acid in water. So we can repeat the same equation with methanoic acid, starting with methane. So here you have a ethyl group. For methanoic acid, you will just have hydrogen. So replace this with hydrogen, methanoate ion, and hydronium ion. Okay, write the balanced chemical equation. Propanoic acid with sodium hydroxide. Again, neutralization is a reaction between an acid and a base. Neutralization always gives you salt and water. So propanoic acid with sodium hydroxide will give you the salts of the propanoic acid with water. So salt and water there. Propanoic acid, sodium hydroxide is a base. This is your salt. Propanoate, sodium propanoate, and water. Salt and water, 2 products of neutralization, always salt and water. So this is one of the properties of acids. Will produce potassium butanoate with when it is neutralized by KOH. Let us see what carboxylic acid will produce potassium butanoate when neutralized by potassium hydroxide. So I see the potassium salt of the acid. So which acid are we talking? Butanoate, butanoic acid. So we have to start off with butanoic acid and potassium hydroxide to get potassium butanoate and water. So this is where your carboxylic acid is. This changed into the salt. Butanoic acid is what will give you. An ester that has the smell of pineapple can be synthesized from butanoic acid and methanol. Okay. So butanoic acid is acid with 4 carbons. Methanol is an alcohol, methane, 1 hydrogen replaced by the hydroxyl group. So liberating a water molecule, esterification is formation of an ester. Esters, if you can go back and review, esters are formed by acids and alcohol molecules combining with the liberation of a water molecule. So this is esterification. Okay. So butanoic acid, methanol, methyl butanoate is an ester. So this is esterification, and this methyl butanoate has the smell of pineapple. Remember, we had discussed esters have flavors. You know, the esters that smell like plums can be synthesized from methanoic acid and 1-butanol. Write the balanced chemical equation, the formation of ester. So methanoic acid, this is butanoic acid. Methanoic acid, 1 carbon. So here, methanoic acid replaced this entire propyl group with hydrogen. That's methanoic acid. 1-butanol, but 4. So 4 carbons, and carbon 1 has the hydroxyl group. So take away the water, and you are creating an ester. So methyl, again, methyl butanoate, it will be butyl, right? You are taking the name of the alcohol. So butyl methanoate. Here, butanoic acid is the butanoate. So methanoic acid will be methanoate. Here, the alcohol is the alkyl group. So 1-butanol. So butyl methanoate will be your ester that smells like plums. So setting up the molecular formula first and taking away a water molecule. IUPAC for this ester. Okay. So this is your acid. 1, 2, 3. 1, 2, 3. 3 carbons. Propanoic acid. Sorry. Propanoic acid. And your alcohol is 1, 2, 3. Propanol. So here, write the name of the carbon chain from the alcohol as alkyl. 1, 2, 3. This is your alcohol. So propanol, propyl. That's where the alkyl part comes from. Propyl alcohol, propanol. And propyl, they have not completed that. We have to complete this. 1, 2, 3. Propyl propanoate. Because this is your acid, propanoic acid, propanoate. Propanol, propyl. Propyl propanoate. So that is the name for the ester, this particular ester, propyl propanoate. IUPAC name. Oh, there it is. Propyl propanoate. That is the complete name, propyl propanoate. Draw the condensed structural formula for ethyl heptanoate, which gives odor and flavor to grapes. So ethyl heptanoate. So ethyl is your alcohol. So we are looking at ethanol. So this part for your structure will be the ethyl. CH3, CH2O. So this is not there. We are not looking at propyl. Ethyl. Heptanoate. So this is going to be 7. Hepta is 7. So 1, 2, 3, 4, 5, 6, 7. 7 carbons. So ethyl heptanoate gives odor and flavor to grapes. So looking at the name, this is your alcohol, this is your acid. This is your alcohol, this is your acid in an ester. Looking at the name, you will be able to set up the formula. Ethyl acetate is a solvent used for fingernail polish, plastics, lacquers. Write the balanced chemical equation for the hydrolysis of ethyl acetate with NaOH. Hydrolysis is breaking down. You're breaking down the ester in the presence of a base. Base hydrolysis of ester. Now, the hydrolysis of ethyl acetate with NaOH gives the carboxylate salt, sodium acetate, and ethyl alcohol. So this is ethyl acetate. Ethyl alcohol. Acetate, this is common name. So ethanoate, ethanoic acid. In presence of base, sodium hydroxide, you get the salt of the acid. There is your salt of the acid, and you get your alcohol. So the base hydrolysis of an ester gives the salt. Base hydrolysis always will give the salt of the acid. So we will discuss that again later in amides. If you see, you remember we did the same thing. Ester hydrolysis in presence of a base will give you the salt of the acid and the ethanol. So hydrolysis again is breaking down. So remember hydrolysis, whenever you see hydrolysis, you will know that you're breaking the ester bond. Here again, this is the bond of the ester where you're breaking the bond, going back to the original components, but you do not get the acid back because of the presence of a base. It gives you salt and water. Draw the condensed structural formula for the product hydrolysis of methyl benzoate with KOH. So your methyl is your alcohol. So you get your methanol back, and you get the potassium salt of benzoic acid. So benzoic acid has a benzene ring, so you get your salt back. So C double bond O, Na. So this is your salt. The positive and the negative are connected through the ionic bond, ionic force of attraction. So methyl benzoate, so this is your alcohol, acid, set up the ester, break the ester bond, this is the ester bond, and create the two molecules, methyl alcohol or methanol and benzoic, the salt of the benzoic acid, the potassium salt of benzoic acid. Amine, primary amine, tertiary amine. So ethyl amine, okay, primary amine. Ethyl dimethyl amine. So ethyl dimethyl amine. So amine has one ethyl group, ethylamine. This amine has two methyl groups, one ethyl. Ethyl propyl amine, ethyl propyl. So there is no di. So we know there is ethyl, this is the ethyl group. Propyl, one more carbon, and propyl. So there will be ethyl, there will be propyl, one will be hydrogen. That is your condensed structural formula, ethyl propyl amine. Primary, secondary, tertiary. So one hydrogen, 2 carbons, secondary. No hydrogen, tertiary. 2 hydrogen, primary. This is a primary, one alkyl, cyclohexyl, to a nitrogen group, tertiary, 3 alkyl, 2-methyl and 1-ethyl. C is a secondary 2-alkyl butyl ethyl, which makes it secondary. Classify the following amine as primary, secondary, tertiary. Let's look. Nitrogen connected to 2, 3 alkyl groups, propyl, ethyl, methyl, tertiary. Amine. Write the balanced chemical equation to show ethylamine, weak base in water, neutralized by HCl. Weak base in water, liberation of the hydroxyl group, and because there, water, liberation of hydroxyl, the hydrogen is accepted by the nitrogen because of the presence of the lone pair. With an acid, you get the salt. This is a base, acid neutralization, you get the salts. And you also get water, but if you remember, we were looking at the amine salts, and we discussed how the amine salts are used in medicine. Draw the condensed structural formula for the salt trimethylamine and HCl. Trimethyl, so this is nitrogen. All 3 hydrogens are replaced by methyl, CH3. So there is CH3, 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 HCl. So you will have N, H, CH3, CH3, CH3 with a positive and Cl negative. So that will be your structural, condensed structural formula for the reaction of trimethylamine with HCl. So you will get a salt. Okay. Now draw the condensed structural formula for the amide product. So this is amidation we are looking at. So replace the OH with the amino group. Replace the OH with the amino. Amidation is formation of an amide. So you are taking the OH and the hydrogen as water. You are taking the OH and the hydrogen as water, and there is your amide, amidation. The condensed structural formula for these, this will be your amide. Amide is carboxylic acid and the nitro group, amino group. Draw the condensed structural formula for the carboxylic acid and amine needed to prepare the following amide. Okay, that's a good question. Let's see. So this is the amino group. This is your acid. So if we are trying to predict where we started off, so this should be my acid. So there has to be a OH group that was lost. So this is methanoic acid, and this should be dimethylamine. So these are my 2 ingredients, the carboxylic acid in this case being methanoic acid and the amine being dimethylamine, because this is where the amide bond is created. So there is a OH and a H that was lost. So I'm putting back those OH and H to go back to the acid and amine needed to give the original molecules. So look for the amide bond. Okay, following amide. So IUPAC name. So IUPAC name is based, I take 1, 2, 3, 4. So we started off with butanoic acid. So butanamide. Okay, this is butanamide. And the amine was N-ethyl. N-ethyl butanamide. So replace oic acid in the acid, the oic acid with butanamide, see there, with the amide. And look at the ethyl group connected to the nitrogen, use the prefix N because the ethyl is connected to the nitrogen, N-ethylbutanamide. N-N-dimethylbenzamide. So you have benzoic acid, which is an aromatic ring with a carboxylic group, and then two methyl groups are connected to the nitrogen. So please work on this. You can start with benzoic acid. Benzoic acid is aromatic acid, aromatic ring with the carboxylic group. Replace the OH of the carboxylic group with N-N-dimethyl. So two hydrogens of the amine are replaced by methyl. There is one hydrogen remaining which is liberated as water using the OH of the acid. N-methylpentanamide. Pentanamide, pentanoic acid, 1, 2, 3, 4, 5. N-methyl, one methyl with the nitrogen. So this is your amide bond. So when you are in the hydrolysis using a base, the amide bond is broken. It's a base, so you will get the salt of the acid. So pentanamide, pentanoic acid, the salt, sodium salt of pentanoic acid, and your amine. So those are the products of hydrolysis of an amide in base hydrolysis. HBr. Now I am looking at draw the condensed structural formula for the products of hydrolysis of amide with HBr. Is HBr an acid or a base? I'm looking at H, and that is an acid, hydrobromic acid. So acid hydrolysis of amide produces the acid and the salt of the amine. So when you are acid hydrolysis, you will get the acid and the salt of the amine.